Hi, in this video we'll be talking about a nice problem solving idea. So the problem says that you're given a 2D matrix ARR with the values in each cell. Okay, there are some initial values and you need to answer Q queries of the form $LRUD. So in short, this basically means that you need to find the sum of rectangle formed by this LRUD or this coordinate that is given to you. That this upper and leftmost corner coordinate is given to you and the downmost and rightmost corner coordinate is given to you. You need to find the sum of values in this green region that is bounded over here, and you need to find the sum of all these elements in this 4x4 region, and that will be the answer for the one query, right? So you need to answer all of these queries. Each of the query will have different regions in the rectangular matrix and you need to find out their sum. Okay, so one obvious way would be to just brute force. Okay, one obvious way is to brute force in the region from like this to this using 2D nested loop, and that would be order n square. Like if the sides are n, it would take you order n square because you might need to sum up the whole matrix. Okay, so to optimize on this, first we can use a 1D prefix sum. For each of the row you keep a prefix sum built earlier, right? You can build a prefix sum for every row initially, and then what happens if suppose you need to find the sum of this region, what you can do is that in this row, okay, in this row you can find the sum of this region. Okay, this is the region that you need to find the sum of in this row. In the next row you need to find the sum of this region, right? So these will be just order 1 calls in each of the row using the 1D prefix sum technique, and there would be at most n number of rows, right? So this would be order n per query, right? So this would be order n, this would be order n per query, right? Per query. So we want to do even better than that. So this would take you like the dimension size, like if you build the row, if you build the prefix sum in a row major order, it will take you exactly equal to the side length of the rectangle, and in a worst case that's order n, right? And each of the row will take you just order 1, right? Each row will take you order 1. Now how do we improve on this? So we use the idea of 2D prefix sum. So 1D prefix sum can only restrict us to like every row, right? You still need to iterate on either rows or columns. So we build something called 2D prefix sums. So how do we build that? Like what is this idea of 2D prefix sums? So we build this P array, okay, P array. Now P of ij will store the sum of values from the top left corner to I comma j rectangle, right? Whatever value comes up in this region, you save the sum of all those values in this cell. So this is what the prefix sum that we are trying to build. Okay, so how do we build this? So P of ij actually means the sum of top left corner to I comma j rectangle, right? This region. So we can build this in a row major order. Now what is this row major order? That you start looping from 0, 0, go on throughout the whole row and then go to the next row. So this loop order is called row major order. Okay, so we can build the 2D prefix sum array in this way. How? Let's look into this diagram very carefully. So let's say we want to build the value of P of ij, that is this red rectangle. Okay, now this cell itself has a value of ARR of I comma j, right? This is initially given to you. Okay, so this value you know. Now since you were iterating on a row major order, this value and this value will already be present, right? When you are calculating this P of ij values, this value and this value will already be present if you are calculating P values in a row major order. So let's say we add P of I minus 1 comma j. Okay, let's say we add this region over here, this region set in green. So this cell plus this green region lives out with this part, right? Like this region over here that is left with us. Okay, so to find and add that, we add P of ij minus 1, that is this cell. This cell stores the sum of this blue region, right? So we added this cell, this green region and this blue region, right? So this all over the cells over here has been calculated, this has been calculated, this has been calculated and added to the answer. But for the green and blue, this smallest square has been added twice, right? This has been added to the contribution as twice. So we subtract this yellow region by using the value p of I minus 1 and j minus 1, because all these values when you're iterating on row major order, when you come to this value, and this value has already been calculated, right? So with that we can easily find out the values of p of ij. So using just these 4 values you can find out the value of p of ij. And since we are doing just a loop from I equal to 1 to n 0 to n minus 1, j equal to 0 to m minus 1, and for each of the cell you just find out the value using these 4 array accesses. So each of the cell takes order 1, so the total time complexity will be order n times m. Like if the cell dimensions are same, it would be n square, or if they are different, it's n times m. Okay, so how is this building this p array is going to help us in calculate any random rectangle? Okay, so suppose we need to find the sum of this region that is shaded in red. Okay, so we first of all add the value p of dr. So dr is the lowermost point, right, downmost right point. So that is this cell. So if we add the p value of this, we have added this whole red region into our answer, right? But these cells did not had to be added to the answer. Like these are some extra addition that we have done, like this is excess, so we need to subtract them out. So we subtract p of d comma l minus 1, that is this cell over here. Okay, we subtract this cell, and subtracting this cell from the initial contribution means we are removing all these elements in this yellow region from the contribution. So now we added all of these things in the red, but we removed these in yellow, so we are left with these many cells in the answer, right? These cells over here in the answer, and these red are fine, but these are some excess cells, so we need to remove something else as well. So suppose we remove this cell over here, p of u minus 1 and d, so this cell over here. Okay, so that gives you have removed these cells once by p u minus 1 r, you have removed these cells using p of d l minus 1, and you have added this red cells once, right? So these have got added correctly, and this part and this part has been subtracted, this part has been added correctly. But if you notice this region over here, this region has been subtracted in this part, and it has been added only once. So it is currently in a negative contribution kind of thing. So we need to remove the contribution of these elements. So we add this p of u minus 1 and l minus 1 to get the appropriate values. Okay, so this is the expression that you use. Okay, so what is the total time complexity for this? So building the whole prefix array would take us order n into m, right? Now for each of the query, you only have to access 4 values, right? Just accessing 4 values give you the value of any rectangle. So this was a rectangle and you accessed 4 values. So for any rectangle you can easily access 4 values, okay, and get the query in order 1. Okay, so the total time complexity would be order n times m in the pre-processing, plus for every query you take 1, so that's order n times m plus q. Okay, so this will be the total complexity for this problem. So that's all for this video. Thank you.